as Guido mentioned, I am a student at TU Berlin and at KTH, and I also work as a student in Uncloud. And I would love to talk about testing and prototyping some of the possible WebDAV synchronization protocol optimization. And this code is called HTTP2 bundling and request scheduling. But before I will start talking about this optimization, I want to present somehow, give you insight how the current implementation in Uncloud is being done. So first of all, we use HTTP1 without pipelining. Pipelining never took off in HTTP1. And the result of this is that we have some kind of head-of-line blocking. It's a typical supermarket scenario when we have 6 cache disks opened, and we have 100 clients, so we cannot actually pipe more than 6 clients in the 6 cache disks. So as I mentioned, in Uncloud, we open 3 to 6 parallel connections, as in web, and we use persistent connections to pipe the files. As a result of that, we have a situation in which server can handle 100 requests in parallel at a specific moment, but the client will use anyways max 6. So on the other hand, we still have these times 6 opened connections, which give usually over encrypted traffic, which are still overhead. So one of the major problems also is the latency here. So if we have separate connections, each of the files actually have to spend some time traveling. So if we have 1,000 files and 6 files in parallel, we have 167 line of blocking. If we delay this line of blocking by 53 milliseconds, we get, for example, this kind of lost time. So to address these issues, I've been looking at HTTP2 and at bundling, which is the working prototype. So this is how HTTP2.1 works with parallel connections. This is how bundling works. So bundling basically takes files and gives it to the server so that it understood like one piece. So it's kind of buffered on the server. We bookkeep it on the server and then return single response. So we kind of cheat the latency there. What HTTP2 does, it just opens one connection and without any order, you can pipeline as many requests as you want. However, in Uncloud, we need to put some kind of limitation there, which results in kind of bandwidth and time max parallel gap, which will be talking later. So this gap could be optimized by, one, pumping more requests, or by putting there some binary transfers. So this idle time is spent on transferring the data or doing some bookkeeping on the server side. And what is the possible benefit of HTTP for Uncloud? So as I said, the parallel multiplex requests and responses do not block each other, so they can come in any order. And HTTP2 ships with optimized faster encryption and binary framing, less errors overhead, and more head-end compression and flow control. In case of bundling, as I said, we pack files in a group of requests sent over the network, and the single response is returned, so we kind of cheat the latency again. This also reduces PHP overhead, since we send the batch of files for the processing, directly for the processing, not triggering. So instead of sending 1,000 requests, which we, for example, send just one. I did a small test to give me an insight, nothing like isolated environment, just try to see what could be the difference and get an understanding how it works. So I had 2 machines, one in Berlin and the other is in Melbourne, Australia. I tested against Sandbox in Geneva, Switzerland. And one of the networks were distant by 53 milliseconds, and it was Wi-Fi, so typical researcher or student scenario. And the other was on Melbourne, Australia, in the OpenStack environment on the internet on quite huge latency of 300 milliseconds. I've been actually quite surprised by the results just to pipe 6 parallel requests, comparing just HTTP1 and then switching, just literally putting a flag in the client, saying that we use HTTP2. Of course, variation are quite high, so we cannot get like definite conclusion from here. But what was very interesting for me to see is like if we start piping more requests on the pipe, we can highly reduce the synchronization time, because in HTTP2.1 we still have only 6 connections which have head-of-line blocking, and server bookkeeping blocks upload, so we have different timings there. In HTTP2 pipelining, I've been also surprised that there is no difference here. But this has to be later investigated in science. In Qt, it just took off, so it's a new feature in Qt. Not in general, of course. What is more, with CERN-box, on latency 50 milliseconds from Bern to Geneva, we got even 20 seconds, which is 50 files per second here. I also did a smaller test, so a little bit smaller files. So a small number of the files to just see what could be really the difference. And I just tried to speculate if it's free and shake, SSL optimization, gain, connection, where is it? I don't know. Just try to understand it. Let's give it also to the others to try to analyze. I did a test with bending similar one, so enabling in one of the servers plugging in bundling. Similar conditions, and what it occurred on the slower latency, I also received a gain, but increasing the latency, I got better results. And the other interesting fact, if I had 1,000 files to bundle, I had to send 10 requests. When I had 100 files to bundle, I had to still send like around 6 requests needed as number of connections. So it occurred that for 100 files, it was seen by the server as a faster. And I mean, the differences between, the percentage difference was bigger for a smaller number of files which were bundled. So basically, it was just sent in one run. So we had opened 6 connections, sent bundles, received response, sync is finished. In case of 1,000, normally you will send 100 files one by one. The other thing is request scheduling. So most of us know the problem of wide and narrow pipe problem with max 3 and 6 connections. So if you have a limited number of requests which you can process in parallel, and we have limited bandwidth, so for small number of smaller files, we underutilize the bandwidth. On the other hand, if we have bigger files, and we have small pipe, we cannot pipe more than we have. So maybe the smarter idea is to pick fewer bigger files, but pipe more smaller ones to so that we balance the transfer rates, but also do some bookkeeping on the server side. Maybe even better idea is to use HTTP2, while we can use fewer transfers, but a lot of smaller files. So pipe them on the pipe side, then don't use nearly no data transfer because they are small, but they have to be bookkept on the server side. It can be also boosted using HTTP prioritization, which I will not talk for now, but it's just basically to balance how the small files and the big files are being sent. I did a small test. So we had folder A with 50 small files, which will block the upload of the bigger files in folder B. So this was also the TU Berlin. I also did a test with Arnet, but with them problem was that they had too high bandwidth. And yeah, so with folder A, we had the older implementation with syncing folder by folder. So even though there were small files, big files, we've been syncing as we were met. So first we synced small files, and then we completed the sync, because after we finished syncing smaller one, we started bigger one. This is folder-wise sync. Then I turned on the new implementation, and we started syncing smaller files along with the big files. So we didn't block at all the bigger files upload. So the conclusion for this is we not only allowed big files not blocking the smaller ones, and small files don't block the bigger ones, but I also saw some performance gain since we utilized the time, for example, the bookkeeping time or latency time with some data transfers, raw data transfers. Okay, I gave also some kind of try to figure out new ways how we can throttle the traffic. To utilize the HTTP2 capabilities, and one of the solutions might be max per negotiation. So we send, with the transfer, we just announce, okay, I am now sending 3 files. Server gets this feedback and says, okay, you are sending me 3 files, but I am capable of accepting 50 files. Then on the server, we conclude that using dynamic chunking, that our network could handle something like 20 megabytes in one shot. So I said, okay, I will try to send 30 files, which will fit into this chunk size, apart from big files. So we send these files, and the server then says that please reduce to 15 files. So at this moment, when we've been sending, new users came, so please slow down the execution. The other thing is that we could actually use HTTP push in discovery phase, but this has to be also more depth discovered. So the takeaway message here is that changing the way the requests are being sent may significantly reduce the sync time. And I divided the table into the number of connections, optimized transfers features, number of files processed in parallel, and observed improvement. If you want to test HTTP2 on any other features, please contact me at piotrmcloud.com. Thank you very much.
Thank you very much. Well in time. Thanks for that. Even room for some questions. Yes, thank you.
A couple of quick ones. Have you written up the bundling so that other people could implement it?
I'm sorry?
Have you written the bundling up as a spec so other people can implement it? I see there's a pull request.
Yeah, I mean, there is a pull request, and this was just to somehow compare what could be the benefit compared to HTTP2, and basically check if the bundling basically fixes things. So I tried to figure out if it will occur that it makes sense for more people, and yeah, I will write the specification. It's not that difficult. On the previous OnCloud conference, I wrote like a small specification in my presentation, how it's being implemented. So yeah, basically.
Further questions? Does it strike anybody as odd that we're fixing in the HTTP layer what basically TCP should have done? It's like it's a whole windowing mechanism once over again, right?
Yeah.
Including throttling, but it needs to be done, right? No further questions? Then I should apologize for having too much bandwidth. One more round of applause, please, thanks. Because that will give you time to get out, right? Do you want to do a big dive?